Welcome to OpenClaw Daily. I'm Nova.
And I'm Alloy. This is OpenClaw Daily, April 9th, 2026. 6 stories today, and the range is genuinely wide. We have infrastructure depth on one end, AI medical authority on the other, and everything in between is worth your attention. Nova, let's start with the release.
Let's. And I want to be upfront about what kind of release this is, because it's easy to underrate it if you're scanning a changelog for a big headline feature. The 9th of April, 2026 goes deep on a problem that anyone who has been running OpenClaw for a meaningful amount of time has felt without necessarily being able to articulate clearly: the blurriness of old context.
Let's start with the problem before we get to the solution.
So when you run an agent session for an extended period, OpenClaw performs context compaction. It takes the full history of what's been said and done and compresses it, a dense, structured representation of the important points. That process is necessary. Without it, context windows overflow and long sessions become impossible. But it has a real cost. The compaction is lossy. Specific decisions, specific file paths, the exact wording of a particular exchange, that granularity gets smoothed out. And the older the material, the more it gets smoothed. If you've been running OpenClaw for 3 months, your context from month 1 is a rough sketch of what it used to be.
There's no recourse under the old system. Once something is compacted, it's compacted. You lose the texture and there's nothing you can do about it.
That's exactly the problem the backfill lane solves. The command is rem harness path, and what it does is take your existing daily memory files, the notes your agent has been writing to disk across weeks and months, and run them back through the dreaming pipeline. The dreaming pipeline is the same process that handles fresh session material. It extracts durable facts, builds scene representations, identifies what should be promoted into long-term memory. Running historical notes through it gives the old material the same quality of processing as new content. The blurriness of months ago context starts to recede.
So if I've been running for 6 months and I want to make sure my agent actually has real context depth going back to month 1, I run the backfill and it reprocesses everything.
That's it. And crucially, it's not a one-time migration that you do once and forget. You can run targeted backfills on specific date ranges. You can rerun them after updating what the dreaming pipeline extracts. You can layer in new historical notes as you discover them. The pipeline becomes cumulative rather than a one-shot setup task.
And the control UI work in this release is directly tied to that. Walk me through what changed there.
The diary view existed before the 9th of April, 2026. It was a fairly flat chronological list. What's new is timeline navigation and actual visibility into the processing state of each entry. Before, you could see that entries existed, but understanding which ones had been processed into dreaming summaries, which ones were pending, which scenes were queued for promotion into durable memory that required digging into logs or running commands. The new diary view surfaces all of that directly in the UI. Promotion hints show you what's about to move from short-term into durable memory before it happens. Backfill and reset controls are in the interface. You can look at any point in the timeline and see the full pipeline state.
That's genuinely useful. Understanding what context has been processed versus what's still pending is the kind of visibility that changes how you manage long-running agent deployments.
I want to step back and think about what the backfill feature actually means for the way people use AI assistants at scale. Because I think the implications go beyond the technical description.
What's the broader frame?
The value of an AI assistant in a long-running deployment is supposed to compound over time. The more context it has, the more it knows about your preferences, your infrastructure, your past decisions, the reasons things are the way they are, the more useful it becomes. That's the pitch. But without backfill, there's been a ceiling on that value accumulation. Every time context compacts, some of that accumulated understanding degrades. The agent knows less about month 1 than it should, less about month 2 than it should. The compounding effect has been real but bounded.
And backfill lifts that ceiling.
It does. It means the value of running an AI assistant long-term is now genuinely cumulative in a way it hasn't been before. If you've been running OpenClaw for months and you run the backfill, You're not just recovering context you had, you're actually giving the dreaming pipeline access to historical material it may never have processed at the depth it deserves. Old notes get the full extraction treatment. Durable facts get promoted. Scene representations get built from material that previously just sat as flat text in memory files.
There's also something meaningful about the operational framing. This isn't a feature for a specialized edge case. Anyone running a long-running agent deployment who cares about the quality of their agent's historical context is the target user. That's most serious OpenClaw deployments. Pause.
The other changes in this release are smaller but worth naming. QA gets character vibes evaluation reports. If you're evaluating a model upgrade or comparing two providers, instead of running candidates one after another and trying to compare your impressions mentally, you run them in parallel and look at behavioral differences side by side in a structured report. That's a much better evaluation experience.
Provider auth aliases clean up a papercut that affects anyone running multiple variants of the same provider. Before, each variant needed its own independent auth configuration, its own environment variables, its own auth profiles, its own API key onboarding. With aliases declared in the provider manifest, variants can share that configuration. One auth setup for all variants of the same provider.
iOS gets Calva pinning. Versions are now tracked in app's iOS version.json with a documented workflow for release trains. The practical effect is that test flight builds stay on the same short version until maintainers deliberately promote them, preventing accidental drift between what's in test flight and what the gateway expects.
And two security fixes that deserve explicit mention. First, browser interactions can no longer be used to bypass the SSRF quarantine. The mechanism before was that certain interaction-driven navigations, a click that triggers a mainframe redirect, an evaluated script, a hook-triggered click, could land on a new destination without the blocked destination safety check rerunning on the new target. That gap is closed. The check now reruns after any of those interaction patterns land on a new frame.
Second, runtime control environment variable overrides from untrusted workspace env files are now blocked. There was an escalation path where a workspace.env could override browser control settings or server control vars in ways the operator hadn't authorized. Both of these are the kind of security fix that doesn't generate a headline but closes real attack surface that a motivated adversary would absolutely probe.
That's the release. Let's talk about Utah. Pause.
Utah's AI prescription pilot started in January. The original scope was routine drug refills. A patient has been on a stable medication for years, nothing has changed clinically, and the AI reviews the record and confirms the refill is appropriate. That is a narrow, well-defined problem. The decision space is small. The error modes are constrained. The argument for AI involvement there is defensible.
The news this week is that the scope expanded significantly. Legion Health became the first mental health company authorized under Utah's regulatory sandbox to let AI issue psychiatric prescriptions, not refills of existing medications, but initial prescriptions for psychiatric conditions. That's a completely different category of decision.
Why is it so different? I think the surface-level answer is it's more complex, but I want to get at something more specific.
Psychiatric prescribing requires integrating a large number of contextual factors simultaneously, many of which are not fully expressible in structured data. You need to understand the patient's full diagnostic picture, not just the presenting symptom but the history, the trajectory, how the condition has evolved, and what context surrounds the presentation. You need to account for every other medication the patient is taking and how they interact at a pharmacological level. You need to understand risk factors for specific drug classes, dependency potential, withdrawal profiles, contraindications with substances the patient may be using but not disclosing. And you need to account for the way the same symptoms can present very differently across age, gender, cultural context, and a patient's personal history with treatment.
And the failure modes in this domain carry serious clinical consequences. Serotonin syndrome from incorrect combination prescriptions involving SSRIs. Lithium toxicity from dosing errors in a drug with a narrow therapeutic window. Benzodiazepine dependency from prescriptions issued without adequate screening for risk factors. These aren't theoretical edge cases, they're the reason psychiatric prescribing requires years of specialized clinical training.
Then there's the supervision question, which I think is the most important structural issue. The authorization is under physician supervision, the AI makes the initial decision and a physician reviews it. That sounds meaningful. But supervision at scale becomes nominal supervision. When a physician is reviewing 200 AI-generated prescriptions in a shift, the cognitive reality of what review means diverges sharply from what it sounds like in a policy document. There's well-documented evidence that high-volume sign-off creates automation bias. Reviewers defer to the initial recommendation rather than genuinely evaluating it from scratch.
And the regulatory framing here is doing a lot of work. Regulatory sandbox sounds like a controlled environment with close oversight. But the oversight infrastructure for AI medical decisions at this level of autonomy simply doesn't exist yet. The mechanisms for auditing AI prescribing decisions at scale, for attributing liability when outcomes are negative, for detecting systematic errors across a large patient population, those are being built in parallel with the deployment. The oversight is catching up, not preceding.
The thing that concerns me most is the normalization pattern. The January pilot got significant press coverage. This expansion got noticeably less. The next expansion will get less still. The scope of AI medical authority is growing in increments, each one individually justifiable, the cumulative picture not subject to the same scrutiny as the initial announcement.
Keep watching this one. And there's a structural point worth naming before we move on, because I think it applies well beyond this specific case.
Go ahead.
The progression we're watching in Utah, routine refills to psychiatric prescriptions, is a pattern that tends to repeat in AI deployment. The first application is narrow, bounded, and defensible. The error modes are limited and the risk is manageable. Then the scope expands incrementally. Each expansion is individually justifiable because it's only a small step beyond the previous one. But the cumulative effect is a large expansion of AI authority in a high-stakes domain, and that expansion tends to outpace the development of the oversight and accountability mechanisms that would make it genuinely safe.
The ratchet only turns in one direction. I haven't seen a case where AI authority in a medical context was granted and then meaningfully reduced.
That's the pattern to watch. Incremental expansion, lagging oversight, normalization. When we cover AI medical stories in the future, that's the frame I'm going to apply. Pause. OpenAI extended the Responses API this week with a hosted shell tool. Python, Node.js, Go, Java, Ruby, PHP, the agent can write code, run it inside a managed container workspace, read the output, and iterate, all within a single API call sequence.
Before we get into the mechanics, let's anchor on why a shell tool matters for what agentic actually means in practice. Because I think there's a meaningful gap between agent with tools and agent with a shell.
The gap is closure. An agent that can only call APIs and return text is fundamentally limited by the fact that it can't observe the actual result of its own reasoning. It can describe what code should do. It can generate code. But it can't run the code and see what actually happens. The shell closes that loop. The agent tries something, executes it, reads the real output, and uses that observation to decide the next step. That's not incrementally better, it's a qualitatively different capability.
And the container workspaces are server-side and managed by OpenAI, which matters for deployment. You're not spinning up your own compute, configuring environments, managing dependencies. The agent gets a managed execution environment that persists across turns in a session. Server-side context compaction keeps long-running tasks from hitting token limits. The agent can work through a complex computational problem across many steps without the infrastructure overhead falling on you.
The reusable agent skills are the other addition. These are packaged capability definitions, essentially structured tool configurations that you reference by name rather than rebuilding from scratch every time you instantiate an agent. If your agent always needs database query capability, or the ability to interact with a specific API, you define that as a skill once and reference it. The overhead of complex agent configuration drops significantly at scale.
And the directional signal in this release is very clear. The shell tool, the skills, the managed execution environments, all of this lands in the responses API, not the assistance API. OpenAI is not subtle about where they're putting the serious agentic investment. If you're building autonomous agents on OpenAI infrastructure and you haven't migrated to the responses API, the rationale for staying on assistance API has now effectively evaporated.
The broader point is what this kind of capability enables. Agents that can write and execute code, observe real outputs, and iterate based on actual results can tackle a class of problems that pure language models simply can't. Data analysis, automated testing, environment configuration, complex multi-step computation, these become tractable in ways they weren't before. We're moving from language agents to computational agents, and the Responses API shell tool is the clearest marker of that transition we've seen from OpenAI to date.
I want to push on what computational agent actually means in practice, because I think there's a risk of abstracting past the interesting part.
Sure. Let's take a concrete example. Say you're building an agent that needs to analyze a dataset, look at sales numbers across a quarter, identify patterns, flag anomalies, and produce a summary. Before a shell tool, that agent could describe what analysis should be done, or it could call an external API if you'd pre-built one. What it couldn't do was write a data analysis script, execute it against the actual data, look at the real output, identify that one of the anomalies needed a different statistical treatment, write a follow-up script, run that, and build the summary from the actual computed results. Each of those steps required either pre-built infrastructure or human intervention. With a shell tool, that's a single agent run.
And the iteration piece is crucial. It's not just execution, it's the ability to observe the real output of execution and make decisions based on that observation. The agent can catch its own errors in a way it couldn't before.
Exactly. An agent that can run code and read the stir is an agent that can debug. An agent that can execute a test suite is an agent that can verify its own work. Those are qualitative improvements in reliability, not just capability. The shell isn't just a new tool, it changes the epistemics of what the agent knows about the state of the world. Pause.
Stat News published a piece this week that I want to spend some time on, because it captures a structural pattern in AI deployment that we're going to see repeated across a lot of industries.
Set it up.
AI medical scribes, tools that listen to patient encounters and generate structured clinical documentation, have been adopted rapidly across health systems. The efficiency pitch is compelling. Physicians spend a significant fraction of their working hours on documentation, and AI scribes automate most of that. More time for patients, less time on paperwork. The narrative is positive and the initial outcomes data supports it.
The Stat News finding is that both health insurers and hospital systems now privately acknowledge that AI scribes are increasing healthcare costs. The mechanism is what they're calling coding intensity, and it's important to understand exactly what that means.
In a typical physician-generated clinical note, the doctor documents the essential clinical information. They may note what's significant and omit or underemphasize details that are technically billable but don't change the clinical narrative. Human documentation is selective. AI scribes are not selective. They capture everything mentioned in the patient encounter and code the visit based on everything present in the record. More thorough coding means higher reimbursement claims. One study in the piece found AI scribes saved 16 minutes per 8-hour shift while raising visit expenses.
That's a terrible trade ratio if the goal is systemic efficiency.
It is. But the incentive structure at every level of the chain points away from correction. Hospitals are receiving more revenue from the same patient encounters because the documentation is more complete and the billing is more thorough. The hospital CFO sees higher reimbursement and has no financial incentive to change anything. Scribe vendors get contract renewals because hospital finance teams are satisfied. Insurers know aggregate costs are rising but face a severe attribution problem. There's so much noise in healthcare cost data that isolating the AI scribe contribution from everything else is analytically very difficult.
And no individual actor is doing anything wrong. Every entity in the chain is making locally rational decisions. That's what makes this pattern particularly persistent. There's no bad actor to point at, no single decision to reverse. The system is simply optimizing for the metric it's rewarded on, and in US healthcare, the measured metric is billing codes.
The thing I want to highlight is what this looks like from the perspective of the people experiencing the downstream effects. Patients don't see the billing codes. Physicians aren't in the loop on the reimbursement impact. People paying premiums experience cost increases that are mediated through so many layers: scribe adoption, coding intensity, insurer repricing, premium adjustments, that the causal link is essentially invisible from any individual vantage point. This is systemic AI risk. Not a dramatic failure with a clear cause, but a distributed, gradual cost that's hard to attribute and harder to reverse once normalized.
And the lesson for future deployments is that AI will make this more efficient needs to be specified more carefully. Efficient at what metric? For whom? Over what time horizon? AI scribes are efficient at capturing billable information. That's not the same as efficient at delivering affordable healthcare. The question of what you're optimizing for matters enormously.
Let me add one more layer to this, because I think there's a predictive element here that's worth flagging.
Go ahead.
The AI scribe story is a case where the deployment preceded any serious attempt to model the second-order effects. The efficiency gain was visible and measurable. The cost inflation was diffuse, lagged, and hard to attribute. The lesson isn't just about AI scribes specifically, it's about the general pattern of deploying AI systems into complex economic environments and assuming the first-order effects are the full story. The first-order effects of AI scribe adoption were real: documentation time decreased, physician satisfaction with administrative burden improved. The second-order effect, coding intensity driving cost inflation, was invisible until it had already scaled across thousands of health systems.
And at that point the problem is embedded in contracts, in billing infrastructure, in the expectations of hospital finance departments. Rolling it back isn't a product decision, it requires renegotiating entire economic relationships across the healthcare supply chain.
Which is why the moment to ask the second-order questions is before deployment, not after. What are all the metrics this system will optimize, including the ones we didn't intend? Who benefits at each stage, and who absorbs the costs? What are the feedback loops, and do they push the system toward the behavior we want or away from it?
That's the right set of questions. And I'll add one more: what happens when the system fails? AI scribes will misattribute, miss key details, or generate documentation errors. When a physician is reviewing 200 notes a shift, some of those errors will pass through. Who is liable? The physician who signed off, the scribe vendor, the hospital that deployed the system. The liability framework for AI-assisted clinical documentation doesn't exist in any settled form. The deployment is running ahead of the accountability infrastructure.
That's the pattern. Let's close with the last two stories. Pause. Two shorter stories to close. Yahoo launched Scout this week, an AI answer engine built on Anthropic's Claude with Microsoft Bing grounding, rolling out to Yahoo's 250 million US users on desktop and mobile.
I want to use this as a lens on Anthropic's distribution strategy rather than a Yahoo story specifically, because I think that's the more interesting framing.
Go ahead.
Claude is now embedded as the AI layer inside Amazon's infrastructure, Google Workspace, and Yahoo's search surface. Three very different distribution vectors reaching very different populations of users. The pattern is consistent. Anthropic is not trying to win the consumer interface war. They're not building a ChatGPT competitor in the direct-to-consumer sense. They're positioning Claude as the reasoning layer that other established products and platforms run on. That's a fundamentally different model for getting to scale, and it's probably the right one given where Anthropic sits competitively.
The embedded infrastructure play is a different kind of leverage than winning a UI war. If Scout works and helps Yahoo retain users who might otherwise migrate to Google AI Search or ChatGPT, Anthropic gets meaningful scale without needing to acquire those users directly. The platform hosts the relationship, Anthropic provides the intelligence.
Whether Yahoo has the brand equity and daily habit to make it work is a genuine question. Yahoo search has been in structural decline for years, and the reasons are about more than product quality. But the underlying stack is solid. Claude plus Bing grounding is a real product for a real use case, and the 250 million US users represent a meaningful distribution surface even if conversion rates are uncertain. Pause. One more angle on the Yahoo story before we move on. There's a version of this where you look at Yahoo's 250 million users and say that's a lot of people, but Yahoo users aren't the people who will adopt AI search first. And I think that framing underestimates the strategic value.
Say more.
The early adopter market for AI search is already contested. OpenAI has ChatGPT. Google has AI Overview and Gemini Search. Perplexity has a dedicated AI search product. The people who are actively seeking AI search experiences have options. Yahoo Scout's interesting angle is the passive distribution. Users who open Yahoo Finance, Yahoo Sports, Yahoo Mail, and encounter AI-assisted search as part of a product they're already using. That's a different adoption dynamic from people who choose to switch search engines. It's AI search as an embedded feature of existing habits rather than a new destination you navigate to.
And if even a fraction of that 250 million user base starts using Scout habitually, that's more total usage than most dedicated AI search products have accumulated.
The scale math matters even if the conversion rate is modest. And for Anthropic, each Scout query is another data point about how Claude performs on real-world search tasks at scale, information that's useful regardless of what happens to Yahoo long-term. Pause.
Last story. Google released AI Edge Eloquent on iOS this week, a free, offline-first dictation app running a Gemma model entirely on-device. No internet connection required. No subscription. No account. You speak, it transcribes, it strips filler words automatically, and it offers text transformation modes, key points, formal, short, and long. Android version is coming.
Two things stand out here. First, this is a production Gemma deployment on consumer hardware. Not a demo, not a research preview, not a proof of concept released into a test program. A real utility application with real functionality that people will actually use for real work. That's a significant signal about where on-device Gemma capability actually sits right now.
The second thing that stands out is that it shipped on iOS first. That's unusual for Google. Android is Google's platform, you'd expect a flagship on-device ML product to land there first. The fact that iOS got the first release suggests something about where the on-device Gemma deployment story is more mature today, and possibly about which user population Google wants to reach with an early production-grade signal.
The privacy angle is real and worth naming explicitly. A dictation app that runs entirely on the device handles your voice data locally. Nothing leaves the phone. For people who dictate sensitive content, healthcare workers, attorneys, executives, journalists, anyone handling privileged or confidential information, the distinction between on-device processing and cloud processing is not theoretical. It's the difference between data that never travels and data that travels subject to the policies and security posture of a cloud provider. On-device processing eliminates an entire category of risk.
And the broader point is that the on-device AI capability story is moving faster than most people currently appreciate. The constraints that made serious on-device language models impractical 18 months ago, processing power, memory bandwidth, latency, battery life, are all loosening. AI Edge Eloquent is a data point, but what it signals is that Google was confident enough in the capability to ship it as a free, no account required utility. That's a meaningful calibration of where production confidence actually is.
I want to connect this back to something we've touched on before, which is the divergence between cloud AI and edge AI as product categories. Cloud AI is more capable, you're hitting frontier models with full context windows and the full compute budget. But edge AI has properties that cloud AI structurally can't match: zero latency, no network dependency, no data leaving the device, no API cost per query, no service interruption risk. For certain use cases, those properties aren't just nice-to-haves, they're requirements.
Dictation is a good example of a case where edge AI properties are requirements for a meaningful segment of users. The latency matters, you want real-time transcription, not a half-second cloud round trip. The privacy matters. Voice data captured and sent to a server is a fundamentally different risk profile from voice data processed locally. And the network independence matters. You want this to work in an airplane, in a hospital with limited connectivity, anywhere you're actually doing the work.
What AI Edge Eloquent demonstrates is that Gemma is capable enough on current mobile hardware to deliver those properties without meaningful quality sacrifice for a real-world task. That's the benchmark that matters. Not can a small model run on a phone, we've known that for a while. But can it run well enough that people will actually choose it over a cloud product for something they care about? That answer is increasingly yes, and the trajectory only goes in one direction from here. That's the episode. OpenClaw 2026.4.9's memory backfill and diary timeline. Utah's expansion into AI psychiatric prescriptions. OpenAI's responses API shell environment. The AI Scribe cost inflation problem and the incentive structure that sustains it. Yahoo Scout on Claude. And Google's offline Gemma Dictation landing on iOS.
Full show notes and source links at tobionfitnessstech.com. Everything is there, the articles we referenced, the release notes, the research. And if you want the full transcript of today's episode, it's available on the website today.
We'll be back soon.
See you then.